lesson 9.5, the distance formula. So, finding the length of a line segment. We've done this a bunch of times. In order to do this, we just go in, we use our Pythagorean theorem. So, I've got 1, 2, 3, 4, 5, 6. 6 units up. 1, 2, 3, 4, 5, 6, 7, 8. 8 units across. We know this is a nice right triangle. So I could expect that this length here we'll call C, the hypotenuse. C equals the square root of 6 squared plus 8 squared, which is going to equal the square root of 36 plus 64, or the square root of 100, which we know equals 10. So now, deriving the distance formula. Today's lesson is on the distance formula. So here, let's start with the Pythagorean theorem. We use the Pythagorean theorem to just find those side lengths of that triangle we just had. A squared plus b squared equals c squared. Well, now we're on a graph, so we have x coordinates and y coordinates. So if we take x2 minus x1 squared, that's like a squared. If we take then our y coordinates, so plus y2 minus y1 squared, that's like looking at our b squared. And all that's going to equal the length of that third leg, the hypotenuse, c squared. So the square root of x2 minus x1 squared plus y2 minus y1 squared, that's what c equals. And here, we can rename c as the distance between those 2 points, which means the distance between 2 points equals the square root of x squared, or of x2 minus x1 squared plus y2 minus y1 squared. Now, let's just do an example together. So, I have this line. First thing I'm going to do, I'm going to find my x and y coordinates I'm looking at. So I'm looking at this point, which is at -5, 2. Then I'm looking at this point over here, which is at 3, -4. So now, I'm going to tell you it doesn't matter what you choose your x1 and x2 to be, because it's always going to be the same thing. So let's write down our distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So you could either declare this point as x1, x2, or as x1, y1, or you could declare this point as x1, y1. Whichever one you declare as x1, y1, you have to declare the other one as x2, y2. So we'll use -5, -2 as our x1, y1, and we'll use 3, -4 as x2, or y2. So we'll have our d here equals the square root of, well, x2 is 3, minus x1, so minus -5, which is plus 5, squared. And to that, we will add y2, -4, minus y1, which is 2. Square all of that. So d is equal to the square root, well, that's 8 squared, that's 64, plus -6 squared, well, that's 36. That will equal the square root of 100, which, once again, distance from point to point is 10. And if we remember from the first slide in today's lecture, exact same line, we used the Pythagorean theorem. Now you just have another way to find it even faster using the distance formula.